A supernova destroyed some of Earth's ozone for a few minutes in 2022. A new study suggests that explosive events in space have the potential to temporarily switch off the natural shield that protects us from harmful solar radiation. On October 9, 2022, telescopes in space picked up a jet of high-energy photons careening through the cosmos toward Earth, evidence of a supernova exploding 1.9 billion light-years away. Such events are known as gamma-ray bursts, and astronomers who have continued studying this one said it was the brightest of all time. Now, a team of scientists have discovered that this burst caused a measurable change in the number of ionized particles found in Earth's upper atmosphere, including ozone molecules, which readily absorbed harmful solar radiation. The ozone was partially depleted, was destroyed temporarily, said Pietro Albertini, an astronomer at the National Institute of Astrophysics in Rome who was involved in discovering the atmospheric event. The effect was detectable for just a few minutes before the ozone repaired itself, so it was nothing serious, Dr. Albertini said. But had the supernova occurred closer to us, he said, it would be a catastrophe. The discovery, reported Tuesday in a paper published in the journal Nature Communications, demonstrates how even explosions that occur far from our solar system can influence the atmosphere, which can be used as a giant detector for extreme cosmic phenomena. Most atmospheric ozone is concentrated in a thin layer of the stratosphere, about 10 to 25 miles above Earth's surface. It was in this region that researchers discovered a hole in the ozone above Antarctica, largely resulting from the use of chemicals called chlorofluorocarbons that were once found in aerosol sprays and plastic foam. The ozone layer absorbs most of the ultraviolet radiation from our sun that can cause sunburns, skin cancer, and crop damage. Simulations have shown that a gamma-ray burst in our Milky Way could wipe out the stratospheric ozone layer for years, long enough to cause widespread extinction. Ozone also exists at lower concentrations higher up in the ionosphere, a part of the atmosphere that stretches from 37 to 310 miles altitude. At those altitudes, it has some protective effect, but much less than at lower heights. To study the effects of last year's gamma-ray burst on Earth, Dr. Albertini and his colleagues looked for signals at the top of the ionosphere using data from the China Seismo-Electromagnetic Satellite, an orbiter designed to study changes in the atmosphere during earthquakes. They identified a sharp jump in the electric field at the top of the ionosphere, which they correlated to the gamma-ray burst signal measured by the European Space Agency's International Gamma-Ray Astrophysics Laboratory, a mission that launched in 2002 to observe radiation from faraway celestial objects. The researchers found that the electric field rose by a factor of 60 as gamma rays ionized, essentially knocking away electrons from ozone and nitrogen molecules high in the atmosphere. Once ionized, the molecule is unable to absorb any ultraviolet radiation, temporarily exposing Earth to more of the sun's damaging rays. Gamma-ray bursts have been known to ionize molecules at the bottom of the ionosphere, up to about 215 miles above Earth's surface. But this is the first time scientists have proved that cosmic explosions like this can affect the entire ionosphere, according to Laura Hayes, a solar physicist at the European Space Agency who was not involved in the study. It is uncommon for faraway cosmic phenomena to cause such large atmospheric disturbances, Dr. Hayes added. Fortunately for us, this gamma-ray burst was extremely distant, making its effects more of a scientific curiosity than a threat, she wrote in an email. According to Dr. Albertini, if the gamma-ray burst was 1,000,000 times larger, it could have ionized enough ozone to weaken the protective barrier for days or months. But the chances of that happening are low, he said. Bursts as powerful as the one that exploded last year are rare, occurring only once every 10,000 years. And because the gamma rays stream out of supernovas jets, they also have to be oriented in just the right direction to hit Earth. Still, knowing how the ionosphere responds to any cosmic phenomena is important for threats that are closer to home. It helps us gauge the recovery time following significant ionization, especially in scenarios involving intense solar flares from our sun. Dr. Hayes said. The good news is that the ozone repairs itself. Eventually, the freed electrons are recaptured by ionized molecules in the air. In this case, part of the shield that protects Earth from the formidable dangers of space was restored, keeping the planet and its inhabitants safe a while longer from the deadly radiation the sun would otherwise send our way. NASA missions study what may be a 1 in 10,000 year gamma ray burst. On Sunday, October 9, 2022, a pulse of intense radiation swept through the solar system so exceptional that astronomers quickly dubbed it the brightest of all time. After spending months combing through the data, astronomers now better understand its scientific impact. The source was a gamma ray burst, GRB, the most powerful class of explosions in the universe. Gamma ray bursts are the most luminous explosions in the cosmos. Astronomers think most occur when the core of a massive star runs out of nuclear fuel, collapses under its own weight, and forms a black hole, as illustrated in this animation. The black hole then drives jets of particles that drill all the way through the collapsing star at nearly the speed of light. These jets pierce through the star, emitting X-rays and gamma rays, magenta, as they stream into space. They then plow into material surrounding the doomed star and produce a multi-wavelength afterglow that gradually fades away. The closer to head-on we view one of these jets, the brighter it appears. Download high-resolution video and images from NASA's Scientific Visualization Studio. Credit: NASA's Goddard Space Flight Center. The burst triggered detectors on numerous spacecraft and observatories around the globe followed up. After combing through all of this data, astronomers can now characterize just how bright it was and better understand its scientific impact. GRB 221009 was likely the brightest burst at X-ray and gamma-ray energies to occur since human civilization began, said Eric Burns, an assistant professor of physics and astronomy at Louisiana State University in Baton Rouge. He led an analysis of some 7,000 GRBs, mostly detected by NASA's Fermi Gamma Ray Space Telescope and the Russian CONUS instrument on NASA's Wind spacecraft, to establish how frequently events this bright may occur. Their answer: once in every 10,000 years. The burst was so bright it effectively blinded most gamma ray instruments in space, which means they could not directly record the real intensity of the emission. U.S. scientists were able to reconstruct this information from the Fermi data. They then compared the results with those from the Russian team working on CONUS data and Chinese teams analyzing observations from the GEC-MC detector on their SATEC-01 satellite and instruments on their InSight HXMT observatory. Together, they proved the burst was 70 times brighter than any yet seen. Burns and other scientists presented new findings about the boat at the High Energy Astrophysics Division meeting of the American Astronomical Society in Waikoloa, Hawaii. Observations of the burst span the spectrum, from radio waves to gamma rays, and include data from many NASA and partner missions, including the NICER X-ray telescope on the International Space Station, NASA's New Star Observatory, and even Voyager 1 in interstellar space. Papers describing the results presented appear in a focus issue of the astrophysical journal Letters. The signal from GRB 221009 had been traveling for about 1.9 billion years before it reached Earth, making it among the closest known long GRBs, whose initial, or prompt, emission lasts more than 2 seconds. Astronomers think these bursts represent the birth cries of black holes formed when the cores of massive stars collapse under their own weight. As it quickly ingests the surrounding matter, the black hole blasts out jets in opposite directions containing particles accelerated to near the speed of light. These jets pierce through the star, emitting X-rays and gamma rays as they stream into space. With this type of GRB, astronomers expect to find a brightening supernova a few weeks later, but so far it has proven elusive. One reason is that the GRB appeared in a part of the sky that's just a few degrees above the plane of our own galaxy, where thick dust clouds can greatly dim incoming light. We cannot say conclusively that there is a supernova, which is surprising given the burst's brightness, said Andrew Levin, a professor of astrophysics at Radboud University in Nijmegen, Netherlands. Since dust clouds become more transparent at infrared wavelengths, Levin led near and mid-infrared observations using NASA's James Webb Space Telescope, its first use for this kind of study, as well as the Hubble Space Telescope to spot the supernova. If it's there, it's very faint. We plan to keep looking, he added, but it's possible the entire star collapsed straight into the black hole instead of exploding. Additional Webb and Hubble observations are planned over the next few months. As the jets continue to expand into material surrounding the doomed star, they produce a multi-wavelength afterglow that gradually fades away. Being so close and so bright, this burst